Hey guys, so what we're going to be looking at right now is we're going to be looking at how we figure out the numbers of the subatomic particles in each type of atom. So before we do that, let's go backwards just a little bit and talk about what an element is. So an element is a substance made of a single kind of atom. So on the periodic table, we have 118 different types of atoms. No two of those elements are the same. So the way I like to describe elements is like dog breeds. So we all know that there are lots of kinds of dogs. You might have a Chihuahua, you might have a German Shepherd, you might have a Border Collie, you might have a Corgi, and those all look really different. They all act really differently. They're all good and or bad at different things, but they're all dogs at the end of the day. Elements look different, they act different. Different elements serve different purposes, but at the end of the day, they're all atoms. They're all just a specific kind of atom. So, what makes up an element? We know that elements are made of three types of particles. They're made of protons, neutrons, and electrons. And the way that we identify atoms or elements is by their atomic number. The atomic number is this number right here. So what we're looking at right here is chlorine. Chlorine is number 17 on the periodic table. The reason that chlorine is number 17 is because it has 17 protons. Every atom of chlorine has 17 protons every single time. The number of electrons can change, the number of neutrons can change, the number of protons never ever changes. And that's a really important thing to know. All right, so we've looked at the atomic number. We know that that is equal to the number of protons. So now let's look down here at the bottom. We have the atomic mass. Now the atomic mass is not a whole number. The atomic mass is a decimal because that is an average of the different possible masses of chlorine. So when we are looking at masses, we are only counting the number of protons and the number of neutrons because, as we've talked about before, electrons are so very, very, very small that they just get rounded out when we calculate mass. So when we're calculating mass, we're looking for this decimal at the bottom, and it is the combination of the average number of protons and neutrons. Okay. So this is the periodic table. It is organized by our atomic number. We go straight across, and as we go across, we continue increasing and increasing and increasing. And we'll look at that in more detail later. So now let's look at how we figure out how many of each type of particle is included in our element. So we know that the atomic number is equal to the number of protons. The number of protons is the atomic number, so there's no math required to figure that out. We look at this, we go, oh, the atomic number is 17, therefore there are 17 protons. We can do the same thing with electrons. No math required. All we do is look up here at the atomic number, and it is going to be the same as the number of the number of electrons is going to be equal to the number the number of electrons is equal to the atomic number when we have a neutral atom. For our purposes, we're going to assume that all of our atoms are neutral. So for my class, you will have, if you have an atomic number of 17, that means you have 17 protons and 17 electrons. Now neutrons is where things get a little bit different. So with neutrons, we have to do a little bit of math. So we're going to do some subtraction. We're going to look at our atomic mass, which is this right here, and we are going to round it to the closest whole number. And when we round, we're going to look to the tenths place. So you learned in math class that if you are 4 or below, you're going to round down when we're rounding to the whole number. If you are 5 or above, you are going to round up. In this case right here, we are looking at our tenths place, and so this is going to round down to 35. So this is going to stay at 35. So what we would do is we would do 35 minus 17, and we would wind up with 18 neutrons, because 17 plus 18 is 35. So that's how we're going to find our neutrons. All right, so let's go on to the next slide. So we're looking at hydrogen. So we're going to figure out our proton number first. So we have an atomic number of 1. When we have an atomic number of 1, we know that that means we have 1 proton and 1 electron, because our atomic number is equal to the number of protons equal to the number of electrons. No math required. The next thing we're going to do to figure out our neutrons is we're going to round this to the nearest whole number. So we're going to look in the tenths place. This is a 0, so we can leave this alone. So we are going to subtract our atomic mass from our atomic number, which in this case just happens to be 1 minus 1. And this is going to give us 0. Hydrogen is the only element that does not have any neutrons. So this is a one-time thing. There's not going to be any other cases where you have no neutrons. Hydrogen is your only example. Let's go to the next one. Now let's look at oxygen. So we know that to figure out how many protons we have, we're going to look at our atomic number. So that means we have 8 protons, we have 8 electrons. So the next thing we're going to do is we're going to do our little bit of subtraction to figure out the number of neutrons. We're going to look here, we're going to round this up to the nearest whole number. So we have a 9 here, so that means we're going to round this to 16. 16 is going to be our mass number. That's what we call that rounded number. So we're going to subtract 8 from 16. And that's going to give us 8. So we have 8 protons, 8 neutrons, 8 electrons. Now there will be times where we will have the same number of each of our 3 subatomic particles. We can have 8 protons, neutrons, and electrons. The bigger the element gets, meaning the bigger this atomic number gets, the less likely that's going to be to happen. But here on oxygen, we just happen to have the same number of protons, neutrons, and electrons. Our next element we're looking at is iron. Again, when we're figuring out proton and neutron number, we're going to look at our atomic number here, and we know that we have 26 of each, protons and electrons. Then we're going to do our little bit of math to figure out how many neutrons we have. So we're going to look at our 55 and 84 hundredths. We're going to look at this 8 tenths, and we know that 8 is 5 or larger, so we're going to round this up to 56. 56 minus 26. And we're going to do our little bit of math, and we know that that's going to give us 30. Okay, so we have 26 protons, 30 neutrons, and 26 electrons. Let's do another one. So we're going to look at nitrogen. Nitrogen has an atomic number of 7. We know that we can look at our atomic number to tell us the number of protons and electrons, because we're assuming this is a neutral atom. And then we're going to do our little bit of a math. This one just happens to be a whole number, so we know we can subtract our atomic number from our atomic mass. So this comes from here, this comes from here, and that's going to give us 7. So this happens to be another example where we have the same number of each subatomic particle, 7 protons, 7 neutrons, and 7 electrons. Last example, we're working with some larger numbers here. So we're going to look at gold. With gold, we have an atomic number of 79. So we know that our atomic number is equal to our protons and electrons when we have a neutral atom. So we're going to take this and we are going to look at our tenths place, and that's going to let us know we need to round that up to 197. So we're going to subtract our atomic number from our atomic mass. We know we can't subtract 7 from 9, so we're going to redistribute. So when we have 17 minus 9, that's going to give us 8. 8 minus 7 is 1. And we have, bring that one down, we have 118 neutrons. All right, guys, so that is how we find the number of protons, neutrons, and electrons for each of our elements.